Hey everybody, how are we doing? It is office hours in the afternoon. What questions are there? We might start with some chapter 4, which I think is due tonight. So let's see. People in class today were asking about chapter 4. I'm going to get that pulled up here. We talked about 320 this morning. So 320 we handled this morning. I'm logging into my Pearson. It's like, do you want to change this setting? I'm like, nah. Get everything turned all the way up. I'm just going to cough. All's good. Who is here? Anyone here yet? Only Mubot. Mubot is the only being here. And let's go right here to assignments. Chapter 4 quiz. Let's bring up chapter 4 quiz. And let's go to preview it. Here we, oh wait, we don't want to preview it. We want to go to the questions. I think we did some of these another day, but never hurts. Replace questions. Oh my gosh, there's so many questions on this. Chapter 4. Oh, I don't think we've done this one yet. Let's see right here. Let's get everything ready to go. We are good to go. Let's hop over here to the quiz. Okay. Chapter 4 quiz. Let's do the questions. What is the range of the data for serials? Now, when you do the range of the data, it's going to be the minimum to the maximum. And you don't want to use the histogram right here because it doesn't give you the information. You might say it's 70, but the minimum number is 2 and the maximum number is 64. So this is going to be a range of 62. When we describe the shape of the distribution, I think it's talking about all the data here, not just one of the values. So the range of the distribution is going to be, the shape of the distribution. If you look at this, you do see that there's 2 peaks to this. Make sure to kind of analyze the data and see that you've got a mode here and you've got a mode here. Modes are kind of areas where data's at. I guess I should say a modal region, which is like a common area. So it is bimodal. Always try to answer these questions before kind of looking at the answers, because then you'll be like, okay, what is the shape of that? Maybe bimodal, little right skew. What aspects of the serial might account for the shape? Well, I love some Lucky Charms. If you look at this, we've got here the adult cereals, which those are horrible, and the children's cereals, which are great. So you see the amount of sugar. I think it says sugar. Yeah, percent sugar. Children's cereal. This might just be like sugar coated something, because this is almost all sugar. And then down here, you've got like fiber one or something horrible that I don't want to eat. So you've got the range of cereals is very different for children versus adults cereals. And what you'll notice here is that what we have is, we would have cereals tend to be either very sugary or high, low sugars. I wish it said something about the adult or children's cereals, and that might be down there in the next question. Are all children's cereals higher than all adults cereals? And the answer is yes. Here's the lowest for children. Here's the highest for adults right here. That's just telling you that this is 64. That's not a value of 64 for this distribution. I wish they made that a little bit more clear by putting it over here. Ooh, what's up, Jacob? Good to see you here. We're going through chapter 4 quiz, and feel free to ask questions, especially if you're stuck on one. We can do that one next. I'm just kind of going through step by step on all these. Which group of cereals varies more in sugar content? So when you look at the variation, they both have similar ranges, but what is different right here, Jacob? What's up, Hannah? So good to see you here. If you have a question, feel free to ask. These are your guys' office hours. You come to office hours, you get to choose what we do. We did a lot of 320 this morning, so I might focus more on 201, but the votes can always walk away. If all 320s come in, they say, we're working on this, as long as they didn't do it every time, I'd be like, okay, we're doing 320. What do you notice? The ranges are similar here. Like, here's the range of adults. Here's the range of children's. And then what is different right here? Like, I see different medians. The medians are different, but also from here to here and from here to here, there's a big difference between adults cereals and children's cereals. Let's throw everyone some 20 points in the chat for being here. It's 20 Point Tuesdays. I need to make more bumpers between. So what do you notice right here with this to this and this to this? Like, this is an important thing. Right here, the bottom of the box to the top of the box, the IQR is larger for adults, exactly. Although the ranges appear to be comparable between both groups, the IQR is larger for adults. That does seem to be, check out. Did we do it? Yeah. Not today, my Pearson. That's one of our quotes. Not today, my Pearson. So we've done it. We have done one of 21 questions. So what do we have right here? We have, what would this be called? This would be called side-by-side stem and leaves with side-by-side box plots. Now, we actually never even mentioned side-by-side stem and leaves, but I want you to think about this. When you have stem and leaves, which if you look at these graphics right over, When you look at these graphics right inside of here, we have side-by-side box plots, but a stem and leaf is a univariate quantitative display of data. So you could do side-by-side stem and leaves. There's side-by-side dot plots. There's just tons of graphics you can do. Like this is just the beginning of like graphics we could use. So side-by-side stem and leaves are an option. Back to, I guess I should have put that on here. Like maybe I'll try to like edit this so you can't tell. But we see here displays of a quantitative Y because we're analyzing the percent of change. And we see here a category like region 1, region 2. So this is a categorical variable up here and a quantitative Y scale. So when we look at this right here, which of these would properly describe it? And you can kind of deduce this because here's what I want us to look at visually. How far can this whisker go above here? How far can this whisker go above? We can deduce the answer. Good to see you here, Sarah. How far can this whisker go above Q3? How far can that whisker go above Q3? So, and we could do this to kind of cheat. Let's go here and take a screenshot of the box. And that whisker can go what? Yep, looks more than that. That whisker can only go how far above Q3? Or how far below Q1 can whiskers go? And what did I take a screenshot of? I took a screenshot of the IQR. That whisker can only go how far above? Good to see you here, Sarah. Well, Sarah's here. How far can this whisker right here go above Q3? The maximum length of a whisker is only 1. It looks to be more than that. So the maximum length of that whisker seems to be what? So here's Q3, and it can only go 1. It can only go 1.5 IQRs. So it can only go 1.5 IQRs. And right now, the IQR, what would you estimate the IQR to be? What does the IQR look to be right here? It starts at about 10, and it goes to almost 30, which that's kind of a good estimate. So what does the IQR look to be? The length of this IQR looks to be about what? How big does this IQR look? And actually, Hannah, you're right. Hannah, you actually figured it out. I didn't even realize it. That Hannah, great job. Congratulations. Thank you, Hannah. You are right that it can only go 30 above. So if it's at 30, it could only go up to about 60. Is it there? Ooh, that's so close. That's so close. I might actually have to run the data. We're going to have to check this. Okay, let's do it. Because I'm worried now. Hannah, you are correct. The IQR is a length of 20, or looks to be about. We're going to double check the mathematics because it is so close that I don't want to guesstimate it. I actually want to check it lest we get it wrong. I'm going to go edit paste with column names. And then what you have to do right here, there's a few ways. We'll do it the easy way. The easy way of doing this is going to be analyze distribution and put both of them in here. And then we can make the stacked box plots like this. And it looks like region 2 does have an outlier. And look at this. It is not 30. The IQR is 19, and that makes this 60 an outlier. So does that make sense right here that if you were to go up 1.5 IQRs, the IQR is 19 right here. We can add the IQR just to see it, but we should know how to get the IQR pretty quickly, that the IQR is just Q3 minus Q1. And then we would add here 1.5 IQRs, which would be, so 9.5, 28.5. So yeah, it would not get to 60, and that would make 60 an outlier. So this is just barely an outlier. That point in the data set right here is just barely an outlier. So that gives a big hint that we're only looking at this graphic versus this graphic. Last but not least, we can look at this over here, and we can see the maximum in this data set is what right now? Let's see the maximum there. That does give it away. What is the maximum value in this box plot right here? Kind of trace over, and what is the maximum value in that box plot? Because we know it has to have the outlier, and then the maximum value in that box plot looks to be about what? If you were to trace over on this number line, to be like, oh, the maximum right here looks to be about where? Where's the maximum on this? So we can see the box plot has a maximum of what? So you want to trace over. This one has a maximum of this versus this one behind my head has a maximum of about, that's about 17 or so. So maximum of 17, no. Maximum over here of about what? What does this look to be? A maximum about 12. Nice job, Hannah. Excellent work, Hannah. Yep. And you can see here, this would be 12, and there is data at 11, and then there's data at 10. 10 right here is going to be the Q3 for this box plot. That's where Q3 is in this box plot, or maybe 9.5-ish. We could look at the jump output, and we could see where exactly it is. It is 10. So 10 is where Q3 is at, and you can see that right here in this box plot. So it might help to kind of make this, and you could make stem and leaves of these inside of jump. So if you're looking at how to make stem and leaf, there's a stem and leaf, and jump is displaying it a bit differently There's tons of ways to display them. We get to a tricky question now. It's going to say this is bimodal, I believe. So region 1 is tightly clustered. Region 1 is unimodal. Don't do uniform right here. Region 2 is bimodal. Around all modes, they are a little skewed to the right. They've got kind of this right flow to them. And region 2 has an outlier. Did we do it? Oh my gosh, what did we do wrong? Bimodals, is it going to be symmetric? Fairly symmetric versus skewed right. Not fair. Not fair. Good thing we put that in the video right here. If you got that wrong, just please tell me. If you're watching this video and you got that wrong, I do think that's a little bit unfair. That's a little bit subjective. You know, I'm going to cheat. I'm going to go right here. And is this the region 2 one? You see, look at this. If you change the way the bins are, that looks to be just right skewed. You really don't see the second mode. Changing the bins, this now has a bin width of 5, changes the way it looks. So it's a little subjective, and I'm betting that this is skewed. Well, one, because it does have outliers and stuff, and that does have a pretty large amount of skew. But I couldn't find any exact info on exam 1 is for the asynchronous. It'll be March 2nd. March 2nd. Great question right there, Kayla. Thank you for jumping in and asking. It'll be March 2nd. So the exam, and so if you go to the asynchronous, I believe under the home tab, you should be able to scroll down and see what's coming up. And really good question. You will see right here, further down, you will see March 2nd is the exam. Does that make sense right there, Kayla? No, feel free to, you can always jump in and ask these questions. I'm more than happy to answer them. You're welcome, Kayla. Thank you for asking. Let's throw everyone 20 points. Kayla, thank you. I want people to come in. I want them to just say, hey, I had a question. Don't wait for me to finish saying something because I just watch the chat at all times. So whenever you have a question, just be like, hey, I had a question about this. When is this? Do we have all day to take the exam? Really good question right there, Lauren. I was actually addressing this during class earlier. I'm going to find out from Terry. Let me email Terry about that. You know what I'm going to do right now? We're going to hop to space. Don't forget. And I'm going to email Terry as we speak. So let me go here and say to Terry, because if I don't do this now, I might forget. Stat tool 1, exam 1. It is March 2nd. Correct. What time will students be taking it? Thanks. Okay. There we go. Terry is the Stat 1 coordinator. Let me change pages so that doesn't show as a tab right there. I've known Terry a long time. He's super excellent. I want you guys to have all the info. So I just emailed Terry about that really quickly right there. So that way we can get some info and we can find out. I'm not the Stat 1 coordinator, so I don't make the big decisions anymore. Oh, such a bummer, right? I have a question about one of the practice questions that was under Understanding Comparing Distributions lecture. Yes, is this under the asynchronous LIDA right there? Which question were you wondering about? Which question were you wondering about? Is it the quiz? Is it one of these? Which one were you wondering about? We'll do that question. I did have an error on one of the questions, and I did change it. One of them said it was uniform. It's supposed to be unimodal, and I re-uploaded the lecture because of it. And then there's a change I have to make for chapter 5. Thank you, anyone who's ever. If I have a little error, I'm so sorry. We can do this one right here. That was it. And if you catch these and I change it, I give out big points. So please email me immediately if you think there's an error. I've spent a lot of break making the modules we have so far, and I have to work more on some more. But I make errors, and we've caught some of them. It's just hard to like review your own work because unimodal and uniform, sometimes you just flip them in your head. But how does uniform look? So just so no one makes the mistake Brian made, uniform means one form. We can just memorize what it means. And uniform is going to look like this. Unimodal is going to look like this. So uniform is one form and unimodal is one mode. I re-uploaded it and gave everyone hundreds. So maybe I should have said that in the announcement, that the error was that it said a distribution was uniform when it was unimodal. So I really felt like that was a big enough error. It wasn't like I didn't make something clear or I didn't mention something. I thought it was a big enough error that I was like, I don't want people thinking that is like, that's unimodal, and up top there, that's uniform. So uniform, one form, unimodal, one mode. But thank you so much. Catch these areas, send them to me. If they're big enough, I'll change them. If it's small, I change it, but I still give extra credit for the people catching these. So thank you so much, Lida. So I really appreciate that. Crowd management strategies monitor accidents at rock concerts. In their database, they list the names and other variables of victims. This is so sad. Click here for the histogram and the box plots of the victims' ages. This is what the 12-year-olds? Come on. So what do we notice about this distribution right here? It is a unimodal distribution with some right skew, very little bimodality. I'm going to say mostly unimodal. I don't really consider that a second mode because you could just like cut that portion off and it would not be a second mode. I'm just kind of like, that's like a small second mode, but mostly unimodal and some outliers. The range of the data looks to go from about 12 to 46. Let's see what it says. Essentially symmetric. Well, they all say essentially symmetric. It's definitely got right skew. And we do see the outliers. So it's between these two right here. And most victims are between 16 and 24. Let's look where the central portion of the data is. 16 to 24. That's where the IQR is. The IQR is between 16 to 24. So most victims are going to be between 16 and 24. That should be correct. What features of the data can be seen in the histogram that can't be seen in the box plot? So the histogram is going to show shape better. Histogram always shows shape. Box plot shows 5-number summary, the min, the Q1, the median, the Q3, and the max. This is just where outlier begins. This is not the maximum because there is values beyond that. Just so you can see, let's zoom in on this. I need to go away. So this is the min, the lowest number. The Q1 is the bottom of the box plot. The median is the line in the box plot. The Q3 is the 75th percentile, and the maximum right here is the highest. Sometimes people put a star for the outlier. It's just preference or like the highest points or things that are very far away. Comes down to preference if you want to put stars on them or not. I don't usually do that. What features can be seen in the histogram? It's going to be the shape. So there's a slight increase. That's shape. We do see the outliers in both. IQR is going to be shown in the box plot, and the median is going to be shown in the box plot. What summary statistics should be chosen? This data is skewed. Who's listening in? This data is skewed. So since the data is skewed, what should we do? And there are outliers. There's skew and outliers. What measure of center should we use? And I wish it would say the center. It does say the center. And that'll give away the next one. Because it has skew, because it has outliers, which we identified at the start, should be pretty clear which measure of center we're going to use. Like this should be like, boom, we always use this when it's skewed. And this goes for 320 also. What measure of center will we use? Nice job right there, Elida. So we'll use the median, and then what goes with the median? So the median always goes with this because it's based on percentages. And you can see the median right here. You can also see around the median right here, the IQR. So the IQR is going to tell us the spread. Nice job right there, Lida. So the IQR is going to be what we would use, and we should get 100. Boom, of course we get 100. Yes, not tricking us today, my Pearson. Here we are with this one we did in another day. We did this one in another class, but it doesn't hurt to do this one. Someone's watching this video and they're like, no, do this one, do this one, do this one, do this one. Because this one's pretty tricky. This is back-to-back stem and leaves or side-by-side stem and leaf plots. This is a quantitative Y, and we should know, let's bring up our all graphics thing, that stem and leaves are going to be quantitative. You see it there in the top left corner. And then you could make back-to-back or side-by-side stem and leaf plots. I don't have them there in the bottom corner all the way over there, but they would be, and just to make sure everyone knows exactly what I'm pointing at, I am pointing right in this box right here. So it would be a bivariate quantitative categorical display right here is side-by-side stem and leaves, because you're just making multiple stem and leaves. Stem and leaves are quantitative, and then you could make multiple stem and leaves and do a bivariate display. And there's just so many of these. I wish I'd put that in that box. We don't, it's not in the notes. Well, no, it's one time in the notes. We just don't list it. We just show one. So hey, that's good. It is in the notes. Someone's like, what, it's not in the notes? So what we see right here is 36.3, and we should see down here, here it is, 36. That is the 36.3. They're just rounding up or down the last decimal. So this looks confusing right here, but they're just going to round this to 36, and that's represented by this. We should see over here 37 somewhere, and we don't. So, or wait, region B. Oh, there it is, 37. I'm just blind. And there's another 37. Let's go in here to the bottom. Do we see 19 in region B? And that rounds up to 19. So that means we're down to graphic B or C, because this rounds to 19 right here. Let's look for a difference in the graphics. So we're just looking for differences and identifying which is which. If you notice right here, this 2 right here has no digits for region A. So we should see 26 and 29. And if we do see it, it'll be this answer. Do we see something that rounds to 26 and 29? The answer is no. I do not see anything that rounds to 26 or 29 in region A. This looks to be the answer, so we should see 36. There's 36. We should see 39. I am so blind. Am I going mad? Where's that? There it is. It's so hard to think I'm going crazy, everyone. We should see 12 and 12 in region A. So where's 12 and 12? We're just kind of checking. There's 12, and then there's the other 12. And you could check this right here, 16, 17, 18, 19. So there's 18, there's 17, there's 19. That is 19. Is there 2 19? Oh, that's 18. 18, 17, 19, and there should be a 16. There's 16. So this pretty much confirms that it is answer C as we go through here and find these numbers right here. And notice how this 16, be able to identify that that goes along with this number right here. Being able to identify which number is which, and let's take a screenshot and show this. I'm going to highlight for you the ones I'm talking about. If you were to look at this number right here in region B, this would be something that rounds to 26. It'd be this one right here. That is the number. If you look at this number right here in region B, that'd be something that rounds to 30. That would be this number right here. If you look at this number, this is something that rounds to 30 in region A. That is this number right here. So you could literally pick out any number. This is something that rounds to 23 in region A. And that is this number right here. It rounds to 23. One last time, there should be 2 things that round to 21 in region A. So here is something, I forget I can use my pen, but here is something that rounds to 21 in region A. And then we should have one more item that rounds to 21, and it is this one. So if you notice, we can pick any number, like something that rounds to 19 in region B, and we have this number right here. So being able to identify the numbers in a stem and leaf and from the actual data is helpful to understand what a stem and leaf is showing you. It's showing you all the data points, and you can kind of see differences between the distributions. They're both bimodal. Those are pretty interesting distributions. Which of the following comparisons is correct? It looks like region A is lower than region B. You can kind of see the center for the data down here and a center for our data up here. So the models for the country A have higher gas prices. So model A looks to have lower, since there's 15 models. So it looks, if you look at A is centered down here and B is centered up here. They're both a bit odd, but I would say that B is left skewed to the left, and B is right skewed. It's just that weird gap right there. It's so crazy. And let's check our answer. 100%, we did it. So we just see that the mean or the center for A is a little bit lower than the center for B. Just kind of look at where you would divide it in half. Did it compare medians? I would compare medians here. So we've got it. Another one down, another question. Here we are with more side-by-side box plots. This is the baseball one. We did this one this week too. This one is best if you bring it over to jump, and we're going to go here, make sure it's tab delimited. We're going to copy the data, and then we're going to jump over to jump, and we're going to go to file. I'll show it the other way. We're going to go here to file, new, data table. Now make sure and go to edit, paste with column names. Edit, paste with column names. It's very important that you see that these are blue. If these are not blue, then that is an error. So these need to be blue right here. Now we're going to go to tables, and we're going to go to stack, and we're going to double click the average home runs right here. So this is going to stack both those columns, and then we get a label. I don't like how this label looks. It's truthfully team A, team B, team A, team B. I just don't like that it does that, but this will be the proper way to analyze it. And let's go to graph builder. Let's put the label on the x-axis. Let's put the data on the y-axis, and then let's go to Boxplots. And there we go. This will be the answer right here. We could get some more summary statistics on it, but this is a lot like your assignment. And now we have a really good visualization of what's going on right here. Like getting the color to it right there. There we go. That is our visualization. Mubot helping out right there with some helpful advice, Mubot. And let's go take a look at the question. It wants to know which of these graphics, well, neither of them have outliers. So it looks like, well, pretty obvious right there. It's going to be this graphic right here. If you look at the similarities, I can appear again now. This one right here. Write a few sentences. The distribution of home runs scored is... They're going to say it's right skew, aren't they? This is more pulled out at the top. If you look at this whisker, it goes more to the high side right here. It's going to be, yes, thank you. Nice job, Hannah, right there. I think this is going to be right skewed, right? Skewed to the right, and League B is more symmetric. So League B is more symmetric. This is pulled to the high side a little bit. The typical average for League A is going to be bigger than League B, is higher, while the variation average runs scored in League A is greater. If you look at the box plots right here, and also the range, I think that one's right. I'm a little worried on that last one, because I would summarize this. I would go into details with the numbers, but they don't always get so specific right here. The two teams both were in the championship games. Did either team score an unusual? So neither team scored unusual. We got 100. Of course we did. So there's no outliers right here. If we did see outliers, they would be unusual amounts. The reason, let's just look over the box plots again. The reason that this is skewed is that you see Q3 to the maximum has more of a pull on it. There's debate to be had. You know what? Let's find out the real answer, because why debate it when we can do statistics on it? Let's go to analyze distribution. Let's put, this is something you don't have to do, but I always want to know the answers. So here we are. The answer to the question is, how skewed is it? We're going to go and answer the skew question by going here, and they are both right skewed. So they are right skewed. We're in a paradox though, because the mean is actually lower than the median for this one, but it's mostly symmetric, to tell you the truth. It's just the weirdness of that right there. So my Pearson, so many things I got to email my Pearson about. This one's super symmetric, even though it actually has a little more than right skew. So there's just debatable things, but also the answers in the video, I hope that it helps. But they're going to say, because this is pulled out a little bit more, there's a little bit more skew. Now, I do agree that there's more variation in A than there is B due to this IQR right here. The IQR is a little bit bigger, and I think the range is also a little bit bigger. So A has more variation. This one, the box plot at least looks more symmetric, but when you look at the data, it indicates a little bit differently. So you can always go to the data. When comparing box plots of two groups, which of the following should be done? Can we compare the IQRs in box plots? So can we compare the IQRs? Let's bring up some box plots here. Can I look at this one's IQR and say, here's the IQR for this one, and here's the IQR for this one? I definitely can. Can I look to see if there's outliers, to see if there's dots? Thank you, Hannah. Hannah, we're throwing some 20 points. Thank you so much, Hannah. Sometimes office hours are so quiet, and I appreciate people being in the chat and replying and answering the questions. Like, sometimes I go quiet because I want people to answer, but then if no one's here, I'm like, no. As we go towards the project, that's when the chat just goes crazy. Compare shapes, for example. Are the box plots symmetric or skewed? Yes, we can do this. And we can compare the medians. There's the median comparison. It's pretty easy to tell. The only one I'm a little worried about is comparing the shape. These are all correct, but if you really want to compare the shape of stuff, you really want to look at histograms. If it said if this said box plots are awesome for looking at shape, I'd be like, no. Box plots, you can get an idea of the shape, but if you really want to look at the shape of the data, you really want to compare the histograms, which I think we have. Here's histograms right here. It is the same data, good. So the histograms give you a better idea of the shape than the box plots. Box plots are just more compact. Like, it wouldn't be the end of the world if I displayed my data like this, and you see we have the summary statistics on the graphic, versus histograms are going to give you more of an idea of what's going on. And if you really want to go crazy by showing so much data, you could go over here and do the stem and leaves, but that just takes up a lot of space to do a stem and leaf. So all of these box plots, histograms, stem and leaves all display univariate quantitative data. You can do stacked histograms, side-by-side histograms, stacked box plots. That's just doing multiple groups for them. But we should know. Which of the following statements is true about a box plot? Let's take a look at our box plot to see which one's true. The center of a box plot is a box that shows the middle half of the data. Is this the middle half of the data? Is this the middle 50%? The center of a box plot is a box, okay, here's a box, that shows the middle half of the data. That seems very, very true to me. That is the IQR, which represents the middle 50% of the data. So that is very, very true. The values which are displayed by a dot or an asterisk are outliers. We don't have any outliers, but that is very, very true that if there was an asterisk down here, that would be an outlier. We just don't have any. The center line in a box plot signifies the median. That is true also. This is the median here. That's the median of the box plot, and this is the median here. So we see where the median's at. Nice job, Hannah. And box plots are great from comparing two or more groups. Yeah, sure. Very subjective, but you got it. Don't you love these subjective questions? It should be like box plots can be used to to create compact distributions comparing more groups. So boxplots are great for like compact displays. A student in our class calculates the upper fence of a boxplot to be 15.2. Her maximum value is... So does this mean it's an outlier? So what they've done is they've created like this box, and then they've said the upper fence, which is going to be 1.5. That's probably not 1.5 IQRs. This is more like 1.5. We got to do this accurately right here. So this is 1.5 IQRs. So yep, you got it right there. So they calculate the upper fence right here to be 15.2, and then there's a data point here at 17, and so that's definitely an outlier. So their whisker would go up to where the last data is, and a lot of people are often confused by this. They say, well, why is this blank right here? It's because there's no data. The highest point within inside the fence would be maybe like 14 or something, where this is at, but there's no data right here, and then this is where the outlier is denoted. So 100%, this would definitely be an outlier. Watch it say no, and I'd be like, you gotta be kidding me. Look at this, we're doing fine right here. We're gonna do this whole thing. A student wants to determine whether or not a value is an outlier. Ooh. Where is the upper fence? I love this question. I wish it didn't give these answers here. It's pretty easy to see which one's the answer. But let me ask this first. What is Q3? Or, well, sure, that's a good question. What is Q3 is 10. And then what is the IQR? What is the IQR? So let's copy this question and let's work it, because I'm sure someone's watching this, and if I solve it too quickly, they'll have no idea what's happening. They'll be like, Brian, that made no sense to me. How did you do that? I don't want someone to think that. I want someone to be like, oh, that's easy. If you want to know where the upper fence is, we just have to do a formula. The formula we have to do, nice job, everyone. Man, chat, we're just on another 10 points. Who thinks this question is easy right now? And I'm hoping if you're watching this, by the end of this, you think this question's easy. You're like, psh, got it. Easy. The formula we should know is, and remember this, that when you have a box plot, your fences are always going to be 1.5 IQRs above here and 1.5 IQRs below here. So you want to go 1.5 IQRs above Q3 or 1.5 IQRs below Q1. So you're just going, like, think about this. Nice job right there, Jacob. You have that outliers are either above or below. So you're going to go Q3 plus 1.5 IQRs. And you go right here and you do Q1 minus 1.5 IQRs. So it'd be important, if we know where Q3 is, Q3 is going to be this value right here, which is the 75th percentile, which is the mark right here. Q1 is going to be right here, and that's the mark for Q1. And now we need to know the median. Doesn't really matter. It's there. Exactly. Nice job, Lydia. Great job with the, I want the notes in the chat. Excellent work. And so now we need to figure out what this is. This is the IQR. And all the IQRs, it seems super complicated. All the IQR, what does the R stand for of the IQR? All the IQR is, think about what the R stands for. What does the R stand for in IQR? What does the R stand for in IQR? The R stands for, nice job, Hannah. It's the range. So all you're doing is just finding the distance these numbers are apart. So the IQR is just the distance. So all you're doing is just you're saying how far is 4 from 10. So all we're just going to do is 10 minus 4. It doesn't matter if you do it reverse. It's just a distance things are away. So now all we're do is go up 6, go up 3, and we start at 10. That means when we go up 6 and we go up 3, we get to 19. And you can solve it through mathematically using the equation we've written right here. But I just like to think about it that you're just going up 1.5 IQRs, and the IQR is 6. So I'm hoping that, I need to vanish. So you're just going up 1.5 IQRs. So find out what an IQR is. It's just the distance of the box. The box itself is that distance. And then go up 1.5 IQRs. And you've done it. We made it pretty complicated right there, but hopefully people understand how to get that answer now. Where would the lower fence be? That one's more complicated. I think the lower fence would be at -5, right? If you're solving this right now, double check in the chat. But 1.5 IQRs is 9. And so you do 4 minus 9, which is -5. which if this data is some sort of positive numbers, you can't get -5. Which of the following is not necessarily an outlier? Nice job on the points right there, Hannah. Which of the following is not necessarily an outlier? The maximum in a data set. Can the maximum be an outlier? Yes. A number which is, that is literally it. An extreme value that doesn't seem to belong to the rest of data. Ooh. Oh, wait. That's the answer. Nice job, Jacob. Great job, Jacob. So does the maximum, this is what it's asking. Does the maximum have to be an outlier? Which of these doesn't have to be an outlier? Does the maximum have to, yeah, exactly. Nice job, Claire. The maximum does not have to be an outlier. And you see that right here, that the maximum in the data set is not an outlier. And visually, we can see this. Let's connect it. This right here isn't the maximum, and it's not necessarily an outlier. So we can always try to connect it to some knowledge right here. This one, some people get this one wrong. Let me explain why, because this one's going to get tricky at the end. Which group had the highest score? Which group? This is the 5-number summary right here of the groups. Boys or girls? There's some sort of test out of 6 points maybe. Which group had the highest score? Pretty easy on this. Which group had the highest score? It would be girls. And girls had the 5.7 right here. I'll show you where people make a mistake. A few people have already emailed me. Don't worry if you did. I'd appreciate it because there's a trick here at the end. 3.5. So all I'm doing to get the range is just taking the distance. They have the lowest min. They have the highest max. That makes sense that the max minus min just to show. Where's my calculator? So 5.7 minus 2.2 is the range. And we'll show where people make a mistake at the end. Which group has the greatest interquartile range? So the girls' interquartile range is 4.1 to 5.6. So there's the girls' interquartile range, and then 4.8 to 3.6. The girls have a bigger interquartile range of 1.5. Please tell me if I calculate something wrong. Which group generally did better on the test? The girls generally did better. They have a higher median, so it's going to be A, B, or E. Girls did better because the median, there we go, that looks right. So we want to compare medians if we're going to compare the average person. Now here is where people make a mistake. This is, and there's a really quick way to solve this. I'll show you the quick way and I'll show you the long way. So are there more boys or more girls here? Are there more boys or more girls in the class? This is what you have to identify, and I'll show you the very quick way to solve this, like instantaneously. I'll show you the instantaneous solve, and I'll show you the long solve, which we actually lucked out on, or maybe we didn't. Yeah, I know what the answer is going to be. Are there more boys or more girls? Are there more boys or more girls? And the answer's up there. In this class, are there more boys or more girls? You have to identify this. There's more boys. So the boys had a 4.1, the girls had a 4.9. That means the mean's going to be a little bit closer for the whole class to the boys' mean. Oh, what did I do wrong? Round to 1 decimal. This one should be right. This one should be right. Really? Let me think. 0.8 divided in half. Oh, wow, I just rounded it wrong. Let me do it the long way then. Not today, my Pearson, not today. Let's try and do it the quick way. That's what I get for trying to do it the quick. Yes, Jacob, that's the long way. I actually got one of the versions of the question where if you assume that it's equal, you don't want to do this right here. You don't want to do 4.1 plus 4.9 divided by 2, 9 divided by 2, which ironically enough, this would equal out to 4.45, which would round up. This is the wrong way though. Let me put a X on this. This is the wrong way because there's not an even amount of boys versus girls. So that's the wrong way right there. Yeah, so you will round it. And I just can't math today in my head. So what you want to do here is you want to do 4.1 times 13, because that's how many boys there were, plus 4.9 times 12 divided by the 25 students. And people are saying that that's 4.48. Is that, wait, is it 4.48? Wait, what did they say the answer is? And this will be 4.5 on the dot. I just really can't math today. That'd be 4.5 on the dot. That's the wrong way up there. And the bottom way is the right way because there's more boys than girls. So I just couldn't math in my head. Sorry about that, everyone. But does everyone see right here? Because there are 13 boys and there are 12 girls. If you do this right here, so this should definitely get everyone. Yeah. So the top way assumes even boys versus even girls. The bottom way is the way to correctly do it. We just actually hit a version of the question where if you do it the wrong way, you'll still get the right answer. So if you were to do the wrong way to solve this one, you would get the right answer and you'd luck out because you wouldn't know that you got it wrong technically, which usually they do a version of this question where, see, I'm gonna do the quick solve on it. So let's go back, let's change it. We could just answer the one. Well, we'll get mad. This one right here, there's more boys than girls, and the boys had a higher. So yeah, this one's gonna solve the same way, but we'll look at we'll finish version of it. Man, they're making all the ones that you get correct either way if you solve it the wrong way or the right way. Will all be, but always make sure to acknowledge how many boys versus girls there are. I must have missed it, but why 4.0? Because of the numbers down here. Does that make sense, Lida, right there? The numbers down here that you see, this indicates the average for the boys and the average for the girls. So you would times this by the 15 boys, you would times this here by the 9 girls, and then you would divide by the total number. Does that make sense, Lida? Yep. So in this another version of the problem right here, you would times this by 15, and you would times this by 14, and then you would divide by 29 total. So make sure it's pretty tricky. Oh no, we're looking at the completed version. This one's fun. No. Okay. Which of these looks to be left skewed? Gosh. Oh wait, so it wants to know 3 statisticians, which box plots for class 1? Oh, well, it's left skewed. Oh, no worry, Lida. Great job. Glad to have you here. Does everyone see that class 1 is left skewed right here? So it's pulled to the left and the tail here is pulled to the left. The next question asks, which of these goes for class 2? Class 2, so here's where people might get confused on this one. Class 2 versus class 3, which of these is more spread out? Class 2 or class 3? Which of these is more spread out? Class 2 or class 3? Which is more spread out? Class 2 or class 3? Like think if you were to take and like smash one out and like spread it out more or push one together, which one's more spread out? 2 is more spread out. So which of these box plots, B or C, is more spread out? Which of these box plots has the data more spread out? Now they both have the same range. Like they both have the same range, but which of them has been spread out more? Correct. C is more spread out because the range of the middle 50% covers a greater area. This middle 50% is tighter, so that kind of gives away that this will be class C, which has a tighter middle 50%, and we should get it 100. Does that make sense how I saw that? The harder question is the last two, because you have to see that the middle 50% for this one's a lot tighter than the middle 50% for this one's more spread out down here. Off topic, but do we need to have to download? I think you can use the online version. Terry was talking about that. I would say since you get Excel free from UT, I would download it. Tell me if there's any issues, Claire. I would highly recommend downloading it. If you have issues, let me know. Terry was sending an email earlier today saying that you can use the online Excel to do it, so you might not have to. If you're able to do it without downloading it, that's good, but Excel is free, so but I understand maybe there's trouble with downloading it, or maybe there's space issue. Funny, because my computer's pretty full of stuff, so I could see if someone's like, I don't have enough space, so we'd email me and we will get it worked out. This one, this one's a tough one. This one right here is an interesting graphic to read, and let's zoom in on it. So with this graphic right here, you're welcome, Claire. What I want you to notice is that we have the winning speeds right here. So here's the winning speed, here's a winning speed, here's a winning speed, here's a winning speed, winning speed, winning speed, winning speed, winning speed, winning speed, blah, 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 all these. And so this point right here represents the 85th percentile was 37 miles per hour. So then when we go back to the questions right here, it says the median winning speed. So I want us to zoom in on this, and I want people to tell me, it's way too zoomed in. It's funny, I need to like not zoom in like that. If you were to trace over here and then trace down, where would the median winning speed be? And then you trace down to right here. What do you think the median winning speed would be? That's 35.5. What is this median winning speed right here as I trace down from that point? The median winning speed would be about what? So I'm in between 35.5. So 34 would be over here. Here's 34, and that's about the 20th percentile. If we go from the 50th over, and then we trace down, we're right about here. So where would this be at? Oh, no worries, HTT. You got this. I'm throwing 20 points. I don't care if people get things wrong. This is when we practice. A little bit bigger than that. A little bit bigger. If you round that, because I'm going to want you to round to 1 decimal. And I'll explain why. If you trace down right here, which way, where are we at? We're going right here. And you trace down. That looks to be, and they've got a plus or minus on this. Here's 35.5, here's 36. Yeah, HTT, it's probably getting close to that, or maybe, and we'll check that answer. We'll see if we would have gotten right with that. I'm going to go 35.7. I'll see if it would have accepted the other one here in a moment. We want Q1 and Q3. So Q1 is going to be right here. And this one's a lot easier. Ooh, I like this one. What is this one going to be right here? I'll zoom in. So where does this trace down to right here? Where does this trace down right here? That's the 25th percentile. Where does that trace down? That one's super easy. Like, we should be able to get this one super close. It's right here is where it traces. We trace over from the 25th percentile, and then we go down to here. Where's that going to be? So look at the number line and be like, okay, this spot right here is where the 25th percentile is. It could be, I would say 34.5. We're going to check some answers here at the end to see if it would give credit for those. There's a plus or minus on these, so I think it would. I'm going to go, watch me be wrong. Let's go to the upper quartile right here. Thank you so much for working along these questions with me. Ooh, see, this one's a tricky one. Do you see if we trace this down right here? This is the 75th. I'm going from 75th percentile, Q3 down, and that's right below 37, right? So what would that be? What would you say for this one? This is right below 37. And there's like a plus or minus of, yeah, HD, this is how I was thinking, 36.8. So 36.8. Now it wants the range of the data. The range of the data, this is a fun question, right? The range of the data is going to go from 31 to 37.6. So 6.6, please tell me if I'm wrong, everybody. So, and keep that open. And then the IQR is about 2.3. The IQR is the distance between these right here. So you can't see. The IQR is the distance between these right here, 2.3, because I'm just subtracting those differences. And there we go right there. Let's look at this. Oh, that's a ridiculous box plot. There's data further out. We can also confirm our answer here, 34.5 to 36.8. So 34.5 to 36.8, that looks to be about right. 34.5 to 36.8. Does this have a minimum that far? This box plot doesn't look to be properly shaped though. It's between D and B probably. Let's take a look. D has an outlier down here. I'm trying to see the big differences. Oh, this one goes up to 40 something. Does our data go up to 40? Our data does not. Our data stops at 37.6. So this one here has to be wrong. So this one, our data does not look like that. This right here goes up to 40. Our data doesn't go up. Quick question, how do you download R tools in R? You have to go to the CRAN server. Send me an email if you can't find it, but go to the CRAN server, and I might even make a video on this later today. Are you on a PC? Because I think it's all PC is having that issue. Look up CRAN server R tools, and it's a thing you download for R. So HTT, tell me, like, I didn't realize this, that they changed something with R with 4.0, and I think people have to have that, and I must have done it so long ago that I didn't realize it. And we'll make sure people have that, HTT. Thank you so much. And I'll make sure you have that. If you can't find it, email me and I'll make sure you have it. We should be between these two now, right? It doesn't go up to 40. And it's between this one and this one. I wish we could just download the data and do it. So it's probably going to be this one. I'm seeing if there's any other key details that are different. This just has too long of a whisker. The whisker, the IQR was what, 2.3? So 1.5, that is basically 4. And that means 30.5. Ooh, that's close. Oh, no, why? Why is it got to be close? The second data point is where? So there should be no data between the lowest point. No, this one has to be wrong now, I'm thinking. Because at 33, there needs to be a big gap in the data between this and the next one. So there needs to be a big gap, and there's not. There's data at 31. See, there's no big gap, so that eliminates this one. It's not this one because there's data here at 32. Just, if you notice this data point right in here, there's data here, data, and so that eliminates this one. It has to be this graphic. Tricky question. Write a few sentences. This is going to be left skewed, it's pulled to the left. The typical horse race has a winning speed of how many miles per hour? So we're going to go for the median right here. The median is going to be 35.7. And most of the horses are between this and this. Man, they just really want you to keep repeating these. So let's see if we got them all correct. And 36.8. And we should. Not today. I don't think I mistyped anything. Not today, my Pearson. Great job. Let's see what would have happened if we put, what was the median you said? I think you said 35.8. My graph like this is cholesterol on the X and width on the 75. So this estimate is really hard to estimate. Yeah, it's sometimes you have to be like, you have to zoom in and be like, let me look really closely at this. And there is a range of answers it accepts. Does everyone see I'm changing this right here? Would it accept this? I don't think it'll accept that. Oh, it did. So if everyone notices, it's got like a plus or minus 1 on the answer. So the answer does look to be 35.7 for this one. And then if you go up 2, it won't accept it. So it's 37 plus or minus 1. So you can, I don't think you can do what I can do, where I can double check. But this one right here, if we got it on the dot, it'd be 34.5, and it does not accept that. So it looks like it's actually 34.4. And so the actual number that it is 34.4, and we were the plus 1. So that will accept this one. Did we get this one on the dot? If we did, we should be able to go down 1 from it. And it does accept that. And we can go up 1 from this answer if we got it on the dot, and we did. So the exact answer for this one is 36.8. Does that make sense right here for those working this problem, that there's a plus or minus 1 on these? So as long as you're close enough, like the IQR right here probably might even have a plus or minus 2 on it. So the IQR is probably a little bit more forgiving because depending how you calculate it. So the IQR, you've really got a nice range of values you can put in for the IQR. It did not like that because I guess you can't get values that are small enough to get that. But the IQR has a little bit more give on it. The range might even have a little bit of give on it. So you can get them, you can be a little bit estimatey, but you do want to kind of look at it very carefully and zoom in a little bit. But we were able to get it first try 100%, which we always like to do here. First try 100%, that's what we do. You're doing the cholesterol ones? Hey, guess what? We got it right here. Okay, so for the cholesterol one, and let's zoom in on it. Okay, so if you notice right here, if it's asking, what numbers is it asking about first? It wants to know which box plot. Really? We're jumping right to the box plots? Well, this is a ridiculous box plot. This would have like all the data would stop at the 75th percentile. Awesome, JG. You got it, JG. And this one looks a little bit ridiculous. Truthfully, if I had to guess, well, obviously it's not B. Let's see here. The lowest value in this one is what? What is the lowest value in this one? It looks to be about 120 or something. So what's the lowest value in this data set? The lowest value in this data set, oh, it is about that. So I think this one's now been eliminated because this one looks to be the lowest value in this box plot is what? I think it was Jacob. Jacob, what is the lowest value in this box plot? The lowest value in this box plot looks to be around where? What's the lowest value in this box plot? It goes from something to 300. So I think I can eliminate this one because it goes from something here to 300. So the lowest value in this box plot, I'd say closer to 150-ish. Here, I'll draw and show you. I would say closer to 150. It is a lot higher. So I would go right here and I'd trace over, and that looks to be about 150-ish. Does that make sense? It's definitely a lot higher. And when you look at the plot right here, that's definitely not, like, does that make sense? That this lowest point is definitely not that one. So we've eliminated this one. This one's just ridiculous. It's because all the data would have to stop at Q3 and all the data would have to stop at Q1. That's not what we see. So now we're between C and A. So let's look for a big difference. Do you see these gaps in the data right here? I think that's going to eliminate this one. There should be no data between like 300 and 350. There should be no data. Like, this is a blank spot of data right here. There should be no data between 300 and up to about 350. There should be a big gap. So when we go from there's 300 and it stops at 350, it might be this data set. It might be this data set. That might be it. And then this right here is about 100 to 150. No, that doesn't look correct. Because that's not, it's below 150, isn't it? That's right at 150. If you look where that's at, that's right at 150. This one's eliminated because this is above 150, I'm pretty certain. And then that means it has to be, I'm trying to remember which ones I eliminated now. We said that this one's wrong. It has to be this one. That does seem to be correct. I also think that this box right here, yeah, it's just we don't have these gaps. So it is C. Yeah, I'm pretty sure it's C. And the good news is after I do this whole process of elimination, basically gives away the answer. The distribution of cholesterols it's mostly symmetric, nearly symmetric right there. The typical cholesterol level is about, so I got to go get the median. What is the typical cholesterol level? What does that look to be? We could cheat and look over here too. Yeah, that gives away the answer right there. The typical cholesterol, that's what you got good. It's about 225. Most cholesterol levels are below the first quartile of, let's go get the first quartile by looking over here. We trace down, oh, really? Oh, this one's fun. We might do the number line better. I think the number line is going to treat us better on this one. Oh, man. Please have a nice range. I'm going to say that's about 195. Oh, my gosh. It's like my least favorite question right now. And the third quartile of, oh my gosh, 255. What is the give or take on these? Whoo! Whoo! Can we go, how much more off can we go on these? Yeah, it's got a nice range. If you look at how different I can make this answer and it still accepts it, so it doesn't like that. It's got a pretty big range on the answer. So it let me put in all the way to 223, all the way up to, yeah, that might be the range right there. Yep, okay. So this one has a plus or minus 5 on it, which is pretty good. I think that's fair. Does that make sense? This question has a plus or minus 5. The exact answer for this is 228. And then if you were to look at how it grades it, it's 228 plus or minus 5. So so probably these have a plus or minus of 5 on them also, I would guess. Like if we go down a little bit on this, you see it still accepts it. And if I got it right on the dot, then it didn't accept it there. We can find out what the middle of it is. So the answer was 196 to be exact. And to confirm it's 196, we can go plus or minus 5 and it should accept it. So we were pretty good on our guess. I guess 195, which was super close. We can check the exactness of this one by going up 5. If I was right on the dot, it accepts it. Yes. Maybe it was a little bit higher though. Oh, I wasn't right on the dot. So it is 256. I said 255. So the exact answer was 256. And so, but it will accept within plus or minus 5 of that exact answer. So I think it's pretty fairish. It's a little hold your breath type kind of question. But does that make sense, Jacob? We now have the exact answers in here, but with the longer number line, they do give you a longer plus or minus on it. So I do kind of like it for that reason. It's a little bit tricky. We're going to finish off the rest of these questions right here. This is very similar. Did we already do this one? Did I put a repeat question on here? So we already did this one earlier, so I'm probably just going to do it pretty quickly right here. Let's see how quickly we can speed run it. Let's start the clock, and we look right here. I see the big differences are between these regions. Let's see if we see some 12s in region A. I do not see anything that rounds to 12. That would round up to 13, so we're down to these two graphics. Do we see 21, 21 in region B? I do not see 21, 21 in region B. If I'm not mistaken, that's going to make it this answer right here. Which of the following statements is correct? Region B is, so the models for region A have a higher, the models for region A is actually a little bit lower. So the models for region A have lower than region B. Here's region A's center, and here's region B's center. It usually doesn't look like this. I'm a little worried. Region A should have 39. That's 39. And all those have 39, though. Region B should have 39, 39 somewhere. Oh, I made an error in here. I made an error. It's not this graphic. I was like, I've done this version of problems so many times. So region B, it's got to be one of these two. It's got to be A or B. So region B should have 38. There's 38. And region A, does it have 31, 32, 32? There's 33, and that makes it this answer. Okay, cool. So region A is actually higher. I did make a mistake. and I've done this problem a lot. I'm like, I usually don't see this shape to it. Region A should have 31, 32, 32, 33, and we see up here 33, 32, 31. So pretty tricky right here. Made a mistake right there, but that should do it. There we go. Really easy. And I was like, I've done this problem so many times that I think I looked at the graphic wrong. And yeah, just don't go too quick. Don't go too quick. What do we see right here? We see a histogram and side-by-side box plots. So with these side-by-side box plots, we can look at, there's some outliers here. We've got much less variation in this deltoid box plot than we do this bicep box plot. Describe the shape of the strength distribution. Shape center. So when you look at this, the strength distribution is going to be unimodal, one mode, and it is symmetric and does not contain outliers. So it's just talking about that one right there. What is the range for the strength scores? They go from 1 to 4. So the range would be 3. Now watch out, because you can tell it right here, luckily. Pretty easy to tell. And they're not talking about both of them yet, are they? What fact about the results of the two procedures is hidden in the histogram? So we're talking about just the histogram right now, right? Because this is unimodal symmetric with no outliers. At least it looks that way until you go down here and you see that you can see the difference of the average values between the two distributions would be right here. Which method had the higher, better median score? So that's going to be right here. The median, I believe, is right there for the biceps. So the biceps is going to have a higher median. The medians for biceps procedure, which is not visible, is higher than the median of the deltoid procedure, approximately 2. Which was the method with the higher median always better? And the answer is no. Here's the minimum, and there are values that are right there. The method with the higher median is not always better because the maximum of that method, nope. The method with the higher median is not always better because the minimum of that method right here is less than the maximum of the other method. It's talking about the minimum of this method is less than the maximum of this. Which procedure produces more consistent results? So this one is going to have more consistent if you ignore the outliers. The deltoid had more consistent results because of all but 2 of the data values for that procedure are in a very small range. That's exactly right. And we should have it. We did it. Pretty tough, pretty tricky question, especially at the start, because I wish they said regarding the histogram. So it should say using the histogram describe the shape of the distribution. So it's starting out with this, then it's breaking it apart. So the first part of the question is dealing with all the data. Then we go into side-by-side box plots right here. So I understand how that could be tricky. Same sort of deal with this. We're going to compare adults and children's cereals. I feel like we've done this one. What is the range of the sugar content of these cereals? We have done this, so I'm going to do it a little bit quickly. Describe the shape of the distribution. It is bimodal. What aspect of the breakfast cereals might account for the shape? So we've got here cereals tend to be either this or this. Are the children's cereals higher in sugar than adults? Are all children's cereals? The answer is yes. There's no outliers. The lowest child cereal is higher than the highest adult cereal. Yes. Which group varies more? The adults looks to have more. Oof. The adults have a larger IQR, but the ranges are similar, which I think is literally the answer. Although the ranges appear to be the same for both groups, the IQR for the adults cereal indicates that there's more variability, and we've done it. A few more questions and we'll have this whole quiz done. Wait, are these all repeats? Or am I just hallucinating that we've done these multiple times? Because we did this one earlier. That's what happens. Sometimes you get the repeat questions when you do them all. So these are back-to-back stem and leaves. No, I don't think we've done this one today. I think we've just done ones very similar to it. I'm going to vanish here. So when you look at this data right here on the far left, you can actually deduce what the answer is. First off, there's some of these that just don't make sense. This whisker is way too far above. That's more than 1.5 IQRs above. So this graphic just doesn't make sense. So we've eliminated this one. Nope, not that graphic. This graphic right here also doesn't make sense because this dot is within 1.5 IQRs. Remember that we go 1.5 IQRs above. So this graphic right here doesn't make sense because it just visually cannot happen. So we're between A and C. We're between A and D, excuse me, A and D. So how about we look at D right here, and we see that D has a maximum of 12. We did do this one today. And we see here that A has a maximum of something like 17. So if you look at region 1 right here, we don't see 17 over here. We see 12, 11, 11, 11, 10. And that would be consistent with this data where we see 12 as the maximum, and there's some data right here for 11 and 11, and 10 is the Q3. So describe the differences in the growth rates. Watch this. We have here that region 1 is tightly clustered. Region 1 is unimodal. We got one mode right here. Region 2 is bimodal. The distributions are mostly symmetric, fairly symmetric. And region 2 has the outliers. There we go. Fairly symmetric. How did I guess that was fairly symmetric and not skewed to the right? Well, that's practice. So, and please tell me if you get this fairly symmetric one wrong again. I don't think that's quite fair. I did say skewed to the right the first time I did this today. There's a little bit of subjectivity in this. A new question and only two more questions to go after this one. Pretty short though. We got this. Here are box plots of points scored during the first 10 games of the season for both Aaron and Jen. But so let's look at this. I'm gonna slow down. Are 320 questions during this? Yeah. Ask a question, Seth. What video is the chapter 4 homework review? And I think we've covered pretty much everything in here, Abby, because a lot of the homework questions are in the quiz. So I did the quiz, but I think chapter 4 homework should be in here too, Abby. If there's one you're specifically working on, put it in the chat and feel free to ask. And Seth, we can do some 320 if you want. I did a lot earlier today, but feel free to ask. Feel free to ask. I think we're... My dad wants to talk to me about some music chords. He spelled chords like you write chords of a cable. My dad wants to talk to me about some musical wiring chords. So what do you notice right here? Just immediately, I was stuck on the part of the back-to-back stem and leaf on the right up. Yes, put whichever one you're doing, and I'll hop back to that question here, and we can do the quiz version of it. And like, there's different back-to-back stem and leaves, and we'll do that one in here, Abby. You got it. What do you notice is the only difference between Jen and Aaron? We've got Jen right here, and they both have the same median. So both girls have approximately the same median, but Aaron has a bigger IQR. So this is Aaron's IQR. So the coach can only take one player to the state championship. Which should she take? It really doesn't matter. I mean, if you want a consistent player, you'd take Jen. If you want a player with more variability, you'd take Aaron. I was following up test 3, but I'm getting error. The following are masked. Can you send me your are you on Discord? If you can send me your RMD, send me your RMD. I might blank the screen for a second because I don't want to show student IDs and stuff. Send me your RMD, Seth. No, Abby, yeah, if you have to go, yeah. We should have it. Oh, what did I do wrong? Wait. Yeah, sorry, that's the answer. Sorry, I should have read the last answer as I get one wrong. No! The answer's in the video now. As I was stating, either or is fine because the both score the same. Oh, it talks about averages right there. We're not doing averages. We're doing 50th percentiles, but A or B is a possible choice because one is more consistent, one has more variability. So do you want the consistent player or do you want the player with more variability? So preference comes into play. Not today, my Pearson. Oh my gosh, look at all these side-by-side box plots. Only one question. Oh, we got this. So describe what these box plots tell you about the relationship between cylinders in an engine has and the car's fuel economy. So if you look, the median is generally decreasing. We also see that there's very little data for 5 cylinders. This is actually all the data. Every single car was getting 21 miles per gallon. So the box plots show as the number of cylinder increases, fuel economy tends to decrease, and I think that's got it. The variability doesn't, I mean, it gets very small here due to limited data probably. There's an outlier here and there's less variability here. The trend looks to be that the median fuel economy is going down. The box plot shows number of cylinders increases, fuel economy decreases. Really, oh my gosh, it's a multiple check. I need more coffee. So we're gonna go with less variability. I'm really not a big fan of that. Sorry about that. This is when I need my I thought it was a one check box for a second here. See, it's so easy to make mistakes on these. It's all the subjective ones. See, that's just due to limited data. It's important to know that box plot right here that looks like this just means every value in the data set is this. Thank you so much, Seth. Every value in the data set is this. This is the same value for all of them. There's no other data than just 21 or 20, whatever that is. And then we see the variability is decreasing. I just wish they did not include 5. 5 cylinders is a very odd car. Maybe a car person's here and tell us about 5-cylinder cars, but I don't normally hear about that. I'm not a car person though. Oh, look at all this data. We got a right skewed unimodal histogram with some outliers right here. So because the distribution is skewed, the median should be used for the center and the IQR should be used for the spread. How many parks would you classify as outliers? Oof. We got to calculate where the fence is at. So let's go find where the fence is at. We do Q3 minus Q1, and then we times it by 1.5. And with this, we're going to add this to Q3, and this will be the upper fence at 147. What have they done to us here? If it's at 147, it's hard to tell, but these points might not be there. So 1, 2, 3, it looks like 3 parks. There are 2 outliers. Are they using standard deviations right now? Let's see. Oh my gosh, this is quite the question. What have I done to us with selecting this question? So there are 2 outliers, there are 3 outliers because the data values are either more than 1.5 IQRs below Q1 or more than 1.5 QRs above Q3. That's exactly what I did right there. And we're using IQRs and medians and Q3s because the data is skewed to classify outliers. Create a box plot. Well, we know there's 3 outliers. Well, that's nice and easy. Since we know there's 3 outliers, we have the answer right here, and this confirms outlier 1, outlier 2, and extreme outlier over here. Describe the distribution. The distribution is unimodal and skewed to the right. 100. Did I seriously do it? Rewind the tape. Oh my gosh. Going too fast, everyone. Literally today, I have a reading problem. And actually, I say that, and I'm not even joking. Funny enough, and I'm just going to say this real briefly here, I actually do have a reading comprehension issue. I actually, when I was in school, had a, what is it? IED, Individual Education Plan. IEP, that's what it is, IEP. Related to my reading issues. So I seriously do have when I read things, sometimes my brain just changes because I was like, I could have swore that said unimodal because I know what unimodal looks like, and that is one unimodal distribution, not uniform. And we even started, yeah, it's IED or IEP, Individual Education Plan, right? IEP. So I totally had something related to my inability to read properly. So don't worry if that's you. It's a lot of us have, like can't read issues. I mean, I say that as like almost like a joke, but it's a serious thing. Like I'm really bad at reading. What does that mean? I can't even think what that is. HDT. Don't tell me what the acronym is. I'm too afraid to think of what acronym I just said. I'm thinking like education, like yeah. I don't know what it is. Is even words in my head that go. It's funny. So one last story on this is sometimes I'll read something and my fiance will look at it and she'll say, "What did you say that said?" Oh, that's what an IED is. See, I watch too much political stuff. That's what an IED is. Yeah. Yeah, that's like I grew up. Yeah, I grew up in the like 9/11 happened in 2001. I was in college when 9/11 happened. I can tell you the spot at Appalachian State I was when 9/11 happened. I was walking across a parking lot to Walker, which is the math building, and the guy goes, "Dude, a plane just hit the Twin Towers." And I was like, "What?" Because I'm from New York. He's like, "A plane just hit the Twin Towers." And I was like, "No, planes don't hit buildings." Like my brain's just like, this doesn't register. And then I went in and literally saw on the TV, they wheeled out a TV. Oh man, people might not know of these things anymore. Like when I was in school, if they brought a TV to the classroom, they had a cart, and the TV had like a big band thing on top of it to like make it so no one would like knock the TV off the cart. So you had this big cart that you would wheel it out to the classroom. And some people probably remember this. Maybe it was still in school when you were in school, but you'd like pull the TV along, and it'd be like this big, like tube TV. And so they had pulled one of those out to the main area and like had put because everyone's just like, what's happening? And so that was on right there. That was like on, we were watching it. And I went to the teacher's lounge actually, or like the office area, and was like hanging out there. And the first day I took my Calculus 3 exam was September 11th, 2001. I remember because I remember that was my Calculus 3 exam day. And then they canceled school the next day at Appalachian State. I think it's still true that the longest thing on the rock was the year after 9/11. Someone painted a mural on the rock. And I think that's the longest thing that's ever stayed on the rock. There was also, last thing I want to say, like I wish I had a picture of this, but there was a guy who in front of Hess Hall painted it, not painted, but did a chalk mural on the ground. The year after 9/11, he went out in front of Hess Hall and did a chalk mural of the firefighters leaving the building. And it was like, I just sat there and like watched him do the chalk mural that day. I just like came out there and just was like, people were just hanging out watching him draw a chalk mural on the ground. And that's one of the coolest things I've seen. And you know what? I'm just going to say this too. I almost miss these simpler times because no one like took there. Hopefully there's a picture of it somewhere, but I just kind of have that memory in my head. And I think now at times we think like, oh, I need to like put this on social media. You know, I make social media stuff, so who am I to talk? But during this simpler time, people just kind of made stuff, or like he just went out there and did that, and he just like, you know, it's just like, and then just washed away in a day or two because he just was like, I'm just gonna do a mural on the ground. This is what I feel like doing. And there's still a lot of people who do stuff like that, and that's, you know, like I wish I could tell him like it made a big impact on me when you were drawing that on the ground, like just to like see you watch you do that. That I still remember to this day. And how many times do you make an impact on someone's life, or like they remember what you did 20 years later? It'll be 20 years ago this September. And how often do people remember something you did 20 years ago? Let's hop to space, and I think we had a question. I think it's pretty cool if you know, helps you do something, and then someone 20 years later is like, oh, I remember this. Oh wait, did you? Oh wait. Hey Seth, wait Seth. Here, wait Seth. I'm gonna delete your thing here, Seth. I'm downloading it. I think it downloaded. Wait, delete message. Message me at Seth. So that way, like don't post your full work. I'm gonna delete your name off this real quick. So that way when I display it, even though I'm about to display some of your work, I'm gonna delete the student ID and change it to 55555. I still remember if I ever show anything like this, and it looks like you're well along your way. And I'm gonna try to see which thing was crashing. So let me see here if Seth's still here. Did I lose Seth? Oh no, Seth, you're fine. Don't worry. Don't worry. Obviously, I'm glad you did while I was doing this. So I can be like, here, like send it to me via message. Does that make sense? Like, no, don't worry. I'm so glad we have the Discord. It's so easy to hop in there and like take a look at stuff. And don't worry, Seth, you're fine. You know, like I'm like, hey, send it to me on Discord. So you're like, oh, I'll just go right here. So like send it to me in a message. Task 3, but I'm getting an error for my sample position equals 3. Task 3. Okay, here we go. I see it. What's it saying? Why would it give that error? I'll pull it up here in a second. Yes, nice job, Seth. Can you send me a screenshot of the error? Because it's working for me. Let me head over to the main screen. I'll show you. It's working. I entered in 555 as the sample. Why do I have 100,000 results? You have 2 numbers, HDT. I'm so sorry about that. Either's fine to use. Sorry for any of the confusion right there. UT giving out 2 numbers right there. Send me your error you're getting. Send me a screenshot of it. Because right now I'm not getting... Your error says... Let me read your error again. The following objects are masked from my sample. Oh! Okay. So I think I actually hit some of that earlier. This. Yeah. Okay, got it. What this is, and let me show you. I need to detach. Let me do this. Detach my sample. Run code. Okay, good. Let me explain what masking is because I understand what we're having now. So now when I run this, it's not going to give that message. Sorry, I was like, what is the error message again? Your UTID is basically saying, oh, that's not that bad. That's easy to remember. So what something means when it's masked is that you have 2 things that do the same thing. So when things are masked, Seth, it means that you have 2 things doing the same thing. So if you attach this again, like after you've already attached it one time, it will then kind of create 2 things that are the same thing. And it'll say like, hey, you already have these things with these names in them. You're now creating this overlapping. There's 2 things that are like using this allocation of name. So like when you have masks, I guess it kind of makes sense. Like you're putting a mask on, like this thing has multiple layers to it. And it's not a very good idea to have things masked. This happened because we ran it a second time right here. So I'm going to detach it. I'll actually have to detach it twice. So I'm going to detach it twice. If now it's no longer attached. Attached means it's accessible anytime from the global environment. If I run it now, it'll say that there's nothing attached. So this means I can't write like XO2 and it'll autocomplete. But when we attach it right here, this will make them accessible via the global environment. And now we can write XO2 and it'll give us that vector. Is this making sense, Seth? What attaching something means to the global environment is that now in the global environment, when I type this right here, it autocompletes and we can get any of the variables pretty quickly as long as we type a certain portion of it. Is there a GPA? I wish it would auto search all of it, but we can get any of these variables pretty quickly right here via the following. So the autocomplete is like amazing. Here's the good news. When you knit, it'll only attach one time. What you might have done, let me see. You only did it one time. I wouldn't worry about it. It's not that, don't worry, it's not that big of a deal. If you got those warning messages when you knit, I would delete them. What you don't want is, and I think I deleted, here, I'll go back to my version of it. What you'd really not want, I'll show you something really bad to have. Will mine knit right now? Will mine knit? I don't know if I put an excessive output point lossage on this. Okay, so mine is running and I'm getting an error. Object data not found 120. Oh, because I was having fun right here. Sure. Oh, wait. Okay, data. Cool. So let's knit this again. Let's see if it works. I'll show you what you don't want to see, and I'll show you what's fine to see. So right now, with what I have, and I'm just knitting to a right here, this is what you generally should get. This is what your assignment's going to look like. Does this make sense right here? Like all of this is fine. Like this advice stuff is fine. This is perfectly good to get. So try knitting yours and see if it looks something like this. With generally, you'd want to read all this output. Like this is not bad to see any of this. Nothing is excessive right here. Everything looks pretty self-contained. But what you don't want to see is you don't want to see something like, and I'm going to make something really bad right here. This is why you know, if you follow along, don't do these things Brian's about to do, because this right here would be very bad to do for your submission of a file. So we're going to get a whole bunch of warning messages now, and it's basically just going to clutter up the output. And we go down here to the bottom, and you see this right here. This would lose you points. If you notice right here, it's printing out this warning message. This is output that we shouldn't be getting. And it's creating this whole like, hey, you're masking these items, you're masking these items, you're masking these items. And you could technically delete this after knitting. That's one way to handle it. Just delete these, you're masking these items, you're masking these items, you're masking these items. But it's coming from this portion of the code right here. So if you just remove that, and we'll just knit to HTML again. Does that make sense, Seth? Really great question, Seth. And how's this assignment coming? How do you feel about it? I'm hoping it's not too difficult. I see you did it the way I did it yesterday during office hours. Great job right there. I'm hoping you're able to like kind of scan through the video and be like, oh, okay. So yeah. Let me see. I can hop over and look at the Discord while we're doing this and take a look. Let's see. I like it. Yes, that's so awesome. You're like watching the screen. Yeah, that's fine. Yep. And then you knitted it. Yep. And then when you knit finally, you'll knit to a Word doc. Yeah, it's looking great. Yeah, and if you look, your knit only looks to be like 2.5 pages. You look a-okay there, Seth. Excellent work, Seth. Let's throw some 20 points to the chat right here. So, Seth, you are doing exactly what I want you to do, it looks like. Keep up the great work. Excellent stuff. Do you have more questions about this assignment? And how does the assignment feel so far? And make sure to look at the rubric. I'm just going to like keep telling people that like the graders are going to go by the rubric. After opening our tools, what do I put in the console? Yes. Okay, so this should work now. HDT, you're going to be the first to confirm that when you go over here, you want to go to the console and go to install, or let's go to the very start of the assignment. I'm in my version of it. Go to the very start of the assignment, and you want to make sure these are commented out, but you cannot knit with these. So you want to put in this right here. Nice. Nice job, Seth. Excellent work. I'll put in some timestamps set later. You want to do something like this, HDT, and tell me if that works after installing our tools. So you just installed our tools, and then you and this should work now. Should work. Everything should be a-okay. Our tools is kind of how it like, it's the tools for how it downloads stuff and gets stuff going. Everything should work with that. If that works, when you run it, it should. I swear, the more coffee I drink, the more tired I am. Lag, we're hitting a lag burst. I think this is the first time we've had lag today. like since the morning. We didn't have any during class. You're good now, Jacob. Has there been any lag today so far? Has there been any lag issues throughout this stream today? It seems like we've been good. I've been trying to get a hold of Suddenlink, and yesterday was really bad. This morning we had like one lag burst. As far as I know, we've only had this one. We've been going 90 minutes right here. I'm worried I'm going to contact Suddenlink and they'll be like, oh, is it? So were you in 201 during class? Was there one lag burst during class for 201? No one was saying like, hopefully it's just like everyone else's end this time. It seemed like it was more my end because it could be YouTube. We really didn't have many problems last semester. And I'm just hoping, like I have this fear that all of a sudden, hopefully it was. This is the first time today, HTT. If everyone got hit by it, then it's probably my end or YouTube. Like if one person says there's lag, then she's like, oh, it's the one person. But then if other people confirm that it's lag, then it's going to be me or YouTube. So it'll be one of those two. And if it's me, then it would be Suddenlink because that's my provider. And if it's YouTube, then I'm like, yeah, that's kind of the worst situation because who knows, maybe YouTube's had issues with streaming quality. I'll probably hop off here in a second. I'll see if other YouTubers have experienced lag over the last few days. Do I know anyone who streams consistently during the day? If you know any YouTubers, ask them. Be like, has your stream been laggy lately? Because there was a point, one time YouTube crashed. So I've been doing this long enough that like one time YouTube literally crashed and I couldn't stream. We called class. It was really weird. YouTube just went down with streaming. So got this error, type zip. Message me on Discord. Let's hop over. Are you on Discord right now, HDT? If you can, we'll leave office hours here. I'll probably hop over to Discord and I'll take a look. Because I probably need to look at that error like specifically. Are you on Discord? Message me and we'll hop right to a Discord call right after I hop off office hours here. Does that sound good to you? If not, I can send you a Zoom link. If you like send me an email, I'll send you a Zoom link and we'll jump to. It looks to be something. I get so scared when things get. Typing URL, type application zip, length. Oh, maybe it downloaded it. It might have downloaded it. I want you to try this right now. Try running library reg class because it might have downloaded it. It'll be, the text will be in red. I get so afraid when everything's quiet right now. I'm like, I thought everything was working. I thought everything was good. Watch Suddenlink be like, you're over your monthly allotment for upload. And I'll be like, it's blue and black. Are you able to hop on a Discord call real quick? Are you on Discord? And then we'll take a look. I can take a look at your screen then and we can try to figure it out. How's that sound to you? Sound good? I don't know if you're on Discord though. It's so easy. I'll stop streaming. No, we're Discord. If not, email me and I'll send you a Zoom link. You'll do it later. Okay. We'll get it worked out. Let's hop back here to space. Put on a little music. Let's hope the stream does not crash. You're welcome, Jacob. Thank you, everyone. Lots of hard work today. You're welcome, Seth. Great work today, Seth. Looks like you're doing great work on the assignment. Hopefully the rubrics are very clear. I tried to make each step-by-step clear. There's one thing I got to update in the rubric. But that's got it for today. I'm going to go answer some emails. I'll be back teaching 320 in just a little bit. But as we like to say, bye for now. Bye, everybody. Bye.